Hello students, welcome to Unit 3 Notes, Section 9.5. I'm going to begin this warm-up, but you can try it on your own. Just pause the video and then restart it. Alright, so it says determine the scale drawing dimensions of a room using a scale of 1/4 inch equals 1 foot. So in this case, for every 1 foot we have a scale drawing, like a blueprint, where it results in 1/4 inches. So here, if a kitchen is 12 feet by 16 feet, what I can do is say, well, 12 feet is, each foot is 1/4 inch, so 12 of those feet. So 12 times 1/4 of an inch. And I can also do 16 times 1/4 of an inch. And that will give me 12/4 of an inch and 16/4 of an inch. And in this case, that ends up being 3 inches. So the scale drawing, and then 4 inches. And so the scale drawing is going to end up being a 3 inch by 4 inch. 3 inch by 4 inch scale. All right, the next one, we have 8 by 10, so 8 times 1/4 inch equals 8/4 inches equals 2 inches. And then 10 times 1/4 inch equals 10/4 inches, which is 2.5 inches. And we can write it, we can write it in a fraction form. I'll leave it as a fraction. So 4, 8, 9, 10. So it's really 8 and another 2. So it's 2/4, or in this case, 1/2 inches. So the answer for this one is 2 inches by 2.5 inches. All right, the next one, laundry room, is 6 by 9. So 6 feet, so 6 times 1/4 inch, and 9 times 1/4 inch. So we have 6 quarters, 9 quarters, and this gets me 1.5 inches. This gets me 2.25 inches. So 1.5 inches by 2.25, because 9, 8 of them, 8 divided by 4 is 2, and there's still 1 left over, making it 9/4 inches. And now we have a bathroom that's 5 by 7, so 5 and 7 by 1/4 inch. Try this again, 1/4 of an inch. We have 5/4 inches, or 1 1/4 inches. And we have 7 times 1/4, which is 7/4 inches, which is 1 3/4 inches. So 1 1/4 inch by 1 3/4 inches. And what we could have done was we could have left them in a decimal form if we wanted. Fraction is fine as well. And that's the warm-up. So what are we talking about today? Dilations. For instance, shrinking or enlarging something, making a scale drawing of something, that is a dilation. So we made something that was bigger, we made it smaller by a certain proportion. So dilation, enlargements can occur, or reductions can occur. The 4 above were all reductions. It got smaller in size. And so this is not, dilations are not isometries. They are not rigid motions, not rigid motion isometries. They are not a rigid motion isometry. Their angles are preserved, but their side lengths are not. So we definitely have congruent angles still, but everything is either shrinking or getting larger. So locating dilation images. So a dilation is a transformation whose pre-image and image are similar but not congruent. They're similar, which we could say proportional. And we're also going to say but not congruent. Let's just move this over just a little bit. Okay. Thus, a dilation is a similarity transformation. It is not in general an isometry. Okay. Which I mentioned above. Each dilation has a center and scale factor n, where n is greater than 0. Scale factor, let's highlight this. This is a vocab word. Scale factor, n, where n is greater than 0. The scale factor describes the size change from the original figure to the image. Therefore, a scale factor is an enlargement when the scale factor is greater than 1 and lesser when it is between 0 and 1. So you can find a dilation with center C and scale factor n. You can use the following two rules. So the image of C is itself, that is C prime equals C. For any point R, R prime is on CR, and CR prime equals N times CR. So an enlargement is when the scale factor is greater than 1. So let's write that out. Let's actually write that. So scale factor, when the scale factor, let's not write that. Let's write enlargement. When N is greater than 1, and reduction is when N is between 0 and 1, and N is our scale factor. Whoops. Where N is our scale factor. Okay. So these are the two things that occur when we have a scale factor. So here, let's take a look. Dilations with a scale factor about the center. So here, about a center. So here's a center. Let's say that A and A prime, those are the center. Because this image right here, in blue you have this image, and in red you have this pre-image. And so you have this image which has a result of 4. Look at this length is 4 over this pre-image with a length of 2. So what you do is to find out your scale factor is pretty easy. What you're going to do is do your image divided by pre-image. So in this case, the image I don't like that line underneath. The scale factor is found by doing that, your image over your pre-image. So we are going to do 4 divided by 2, which is 2. So this scale factor is 2. And it literally is because it doubled in size. And so you got to do your doubled size. You got to take your image, which is this outer one, and divide it by this inner one. Now, if that's 4 and that's 2, but this is 6, that will be 3. If this is 6, that will be 3. And if this is 4, that will be 2. Everything's proportional. So we just need to know one side and how it relates. We don't need all 4 of the sides at the moment. Okay. Here's another example where a scale factor is 4. I'm going to make up some lengths though. I'm going to say that this was a scale factor of 1/4. I'm going to say, I don't know, that was 4, maybe that was 6, that was 4, and this was 8. Totally making these values up. Well, if that was the case, 1/4 of it would have been 1, 1, 2, and 1.5. So we would have had 1, 1, 1.5, and 2. And I know this because I would have taken any one of these numbers. I would have done pre-image. No, I'm sorry. I would have done image over pre-image. Give me one sec. Image over pre-image. And I would have had 8 over 2. I'm sorry. I messed that up. 2 over 8. So I'm going with my inner one and my outer one. 2 over 8, which is 1/4. Which is why the scale factor here is 1/4. Okay, and I could have done any of them, 1.5 over 6 or 1 over 4. I'm going to erase that and make this look more like one word. Okay, and there we are. So what else is happening here? Well, if we're determining that this has a scale factor of 4, the reason is because we can pick any one of these coordinates because here's my center. Oh, I know what I meant to do. So here, that was the center. Here, this is the center, but it doesn't matter. Okay, for this one, here's the center. So I'm going to literally do image over pre-image. And so it's going to be 8 over 2, or I could have done 4 over 1. Look at this, 8 over 2, or 1, and 4. Whoops. So I could have done either that 8 over 2 or 4 over 1, which is still 4. So the scale factor simplified is 4. For this one, we have, here's our center. And it looks like we can do through, whoops. We got to be careful. We always got to do image over pre-image. So the image has a coordinate of 3 and 9, and 9 is the image, or, sorry, the pre-image is 9. The image is 3, or we could have done -2 and -6. So I would have done, or -2 over -6. Well, this ends up being 1/3, and this ends up being 1/3. So the scale factor, oops, so I have to pair it now. The scale factor is 1/3, and that's noted here. Now, how does that affect it? Well, you notice it's done through multiplication. So our new rule is our scale factor is x comma y maps onto, remember we said n is our scale factor, so it's going to be n times x comma n times y. Same thing here. n times x or n times y is your scale factor times your x coordinate and your y coordinate. Because let's look. 2 times 4 will be 8, and 1 times 4 will be 4. It's almost like I'm distributing to each one of these items and sending it. Here's your 1 cycle, here's your 1 factor, 2 factors, 3 factors, 4 factors. If your scale factor is 1, it's the same thing as your regular coordinate, as your regular ordered pair. It's not going anywhere. It's staying 1 unit. But 2 would double it, 3 would triple it, and 4 would quadruple it. Same thing with this one. You have 9, but you're reducing it by a third. So it's 1/3, 2/3, 3/3. But you want 1/3 remaining, so you have to remove 2/3 of it to get it to exactly where you want it to be. Okay, and so when we dilate triangles, which we do a lot, or quadrilaterals or whatever, or sometimes parallelograms, and we want to find the dilation, but we use its vertices to do so. So here's an example. Well, let's take a look. The blue triangle is a dilation image of the red triangle. Describe the dilation. Take a look. What do we think? And the answer is not 2. Be careful. This right here is the image. The whole thing. The image is 12 long because it's both 4 and 8. Where the pre-image, this is the pre, is only right there, it's 4. So be careful. The pre-image is 4. So when we do this, we're going to do image. We're going to do image over pre-image. Which is going to be equal to 12 over 4, which is 3. So it has a dilation with scale factor. With scale factor with scale factor 3. Okay? Remember, if it had a scale factor 1, it would be this exact same triangle. Nothing would change. This would be x prime, t prime, and r prime. That's a scale factor of 1. This is a scale factor of 2. Not that. Maybe this. Nope. It does not want to make a line. There we go. So that's your scale factor of 2, right? That's your 4, and your 4. But yeah, that's 3 scale factors right there. Oops. Okay, and you see 1, 2, and 3. All right. Next one. The blue quadrilateral is a dilation image of the red quadrilateral. Describe the dilation. So here we have blue has a length of 4. Oh no, we're counting by 2s. No, we're counting by 1s. So I'm going to pick any side. This side's diagonal, so this one's not going to be that easy to find the length of. That one's diagonal, pretty tough as well. That one's diagonal. That's pretty tough, but this one's not diagonal. So I'm going to work with this one. I'm going to call that one 2, because it looks like it's 2 units, because it looks like I'm counting 1, 2, 3. So it's 3 long there. That's 2 long. And then this is 4 long. And so I'm going to do image over pre-image. You know what? I can literally just copy paste everything above and change the numbers. It says describe the dilation. So I'm going to change this. Oops, I do want to change the color to green. Okay, what do we got? The image is 2, and the pre-image is 4. That makes it 1/2. So my scale factor is 1/2. Remember, this is my image, that's my pre-image. All right. The packaging lists a car. So here's a real world example. The packaging lists a model car, that has a length of 7.6. It also gives a scale as 1 to 63. What is the length of the actual car? So here we are. We're going to say the model car has a length of 7.6 centimeters, and that is to some amount of centimeters. And we're also talking about 1 centimeter to 63 centimeters, right? So what I need to do is to find out how many centimeters. I would, in theory, in actuality, I would be multiplying this by 7.6. So I need to do the same to find that. So multiply it by 7.6. So 63 times 7.6, and it was, what was it? 63 times 7.6. We get 478.8. 478.8. 478.8 centimeters. So again, the packaging lists the model's car length as 7.6 centimeters, very small. It also gives a scale 1 to 63. So multiplying this by 63 will get me to the length of the actual car. So we're going to say the actual car's length, let's say actual car's length is 478.8 centimeters. Okay, which is, almost half a meter. Okay, 63. Let me just make sure I did that right. 63 times 7.6. Yep, 478.8. Just seems small. Okay. The height of a tractor trailer truck is 4.2. Is that what they did? Hold on one sec. Let's see if 478.8, that just seems unrealistic. Half a meter. Half a meter. Let's see what the textbook says. That's chapter what? 9.5 or 9.5. Nine 3, 9 4, 9 5, model car. 4.8 meters. I'm doing my algebra wrong. 100 centimeters in a meter, not 1,000. 4.8 meters. That's what they want. So that was my point, is like, let's make this realistic here. So 4.8, so we could even say approximately 4.8 meters. All right, that makes way more sense. Yep. Okay, the height of a tractor trailer truck is 4.2 meters. The scale factor for the model of the truck is 1/54th. Find the height of the model to nearest centimeter. Yeah, I'm going to have to take this value here, 4.2 meters, and multiply it by 100, because there's 100 centimeters in a meter. That gives me 420 centimeters. And so now it has a rate of 1/54. So I'm going to take 420 times 1 out of 54. So that is 420 over 54. Okay, and this is 420 over 54 is 7.77. Let's see if it gives me a fraction. 79ths, yeah. Let's go back. So 7.77. So it's going to be about 7 and 0.77 repeated centimeters. Or this is actually 7 and 7/9 centimeters. Okay. I don't expect you to know that. 7/9 is 0.77. Anything that repeats like that, you just do it over 9. So like 7 over 9. Yeah, if it's like 0.88888, that's 8 over 9. Okay, but yeah. So this would have been, and then if we convert it, we would have got 9 times 7 is 63. That would have left 7/9 left over out of that fraction. Again, this is fine. You could have left it as that. So we're going to say the height of the model, I'm going to answer in a full sentence. The tractor trailer truck model is 7.77 cm, is approximately. And there we are. Oh, it says to the nearest centimeter. Whoops. So let me fix that. Nearest centimeter would be 8 centimeters. Okay. You know what? Let me just clean this up a little bit. I think I can get this all on one line. That would be nice. Okay, and just a little bit more. Boom. There we go. All right. Next one, graphing dilation images. So here we have PZG, which is at 2, 0, 1, -2, and -1, 1/2. What are the coordinates of the image with a center as 0, 0 and a scale factor of 3? So what we're going to do is we're going to use our rule, which is x comma y. Our dilation rule will be 3x comma 3y. So I'm going to multiply everything by 3. So let me take P, which is at 2, 0, Z, which is at -1 comma 1/2, and then G is at 1 comma -2. is at 1 comma negative 2. And the mapping of this is going to be, I'm going to multiply it by 3. So it's going to be P prime is 6, 0. Z prime is at negative 3, 3/2, or 1.5. And G prime is going to be at 3 comma negative 6. And it says, what is the image of P? Now I went all out. All I needed was P, so I would have been able to answer it with just one step, but I would just want to show you where everything is ending up. Okay, and now the next one says, find the image of PZG for dilation centered at 0, 0, and a scale factor of 1/2. So let's copy and paste this over. What I am going to do is change the colors up a little bit. This is going to be blue and okay, and let's get rid of that, and it's going to be 1/2. And these are all going to change. So that's all gone. And we have, that's going to be 1, 0. It's going to be negative 1/2, comma 1/4. Half of a half is a fourth. And then we have 1/2, comma negative 1. And it's going to look crazy on here. If I were to actually graph this, 1, 0 is there. And then it's what? Negative 1/2, 1/4. I mean, this is so small. There's no, I wouldn't expect you to graph this. So don't worry about graphing. So small, don't graph. It's too difficult to graph. Let's just leave it. That's all right. Okay, and we are done. So now you are on your homework. Just be careful. I want you to be careful here. For numbers like 4, don't count the pegs. If you count the pegs, you'll get this. You'll get 1, 2, 3, 4, 5, 6, 7 pegs. It's not 7 pegs. It's the length, which is 1, 1, 1, 1, 1, 1. This has a length of 6. Okay, and this has a length of 2. So be careful that you're not counting the wrong one. And don't forget, the blue figure is a dilation. So the blue figure, blue is a dilation image of the red. So this is your image. So it's always going to be blue over red because your red is your pre-image. So it's always going to be 2 over 6. So 2 over 6 equals 1/3. And so on. So you should be able to do all of these. And we'll be doing them in class, but you can always get a head start. But that's it for this video. Wait, let me see if there's anything. I hope those all look reasonable. This one can be a little bit difficult, but we'll do that. We'll do all those in class. All right. Good luck. Work on your Excels.